Find the value of curl v if the vector v equal to I into vx plus j into vy plus k into vz. Actually, curl of a vector is called rot of a vector because to study the rotation motion of fluids we are taking curl. Del operator is I into dou by dou x plus j into dou by dou y plus k into dou by dou z cross I into vx plus j into vy plus k into vz. So take the curl v. Just we have to present the things inside the determinant. I j k, the operator, dou by dou x, dou by dou y, dou by dou z. Then write down the coefficients of I j k of v. Here vx, dy, vz, which is equal to I into dou vz by dou y minus dou vy by dou z minus j into dou vz by dou x minus dou vx by dou z plus k into dou vy by dou x minus dou vx by dou y. Then this is modified as I into dou vz by dou y minus dou vy by dou z plus j into dou vx by dou z minus dou vz by dou x plus k into dou vy by dou x minus dou vx by dou y. This is curl v. So curl of a vector is also a vector. See this problem. Prove that curl r equal to 0. You know the position vector r equal to I into x plus j into y plus k into z. Then del cross r equal to I into dou by dou x plus j into dou by dou y plus k into dou by dou z cross I into x plus j into y plus k into z. Now the operator dou by dou x is allowed to operate on x, that is 1. Then I cross I cross I plus j cross j, then dou by dou y of y is 1. This is j cross j plus k cross k, dou by dou z of z is 1. You know that I cross I is 0, j cross j is also 0, k cross k is also 0. Then curl r equal to 0. Now see this problem. If vector f equal to I into x plus 2y j plus 3z k, then find curl of f. For that we have to use the identity curl of equal to grade of div f minus del square f. Now find out the div f. Del dot f which is equal to I into dou by dou x plus j into dou by dou y plus k into dou by dou z dot the value of f is I into x plus 2y into j plus 3z into k. Now allow this I dou by dou x dot ix. I dot I 1. Allow this operator dou by dou x to operate on x. Then we can get 1 plus j dot j 1. Dou by dou y of 2y is 2 plus k dot k 1. Dou by dou z of 3z is 3. Then del dot f is equal to 6. Now find out grade of div f. Grade of div f equal to I into dou by dou x plus j into dou by dou y plus k into dou by dou z of 6, which is equal to 0. Because it is a constant, if you allow the operator to operate on it, we may get 0. Then come to our second step, del square f. Del square f, which is equal to del dot del into f. Del operator is known to you. I into dou by dou x plus j into dou by dou y plus k into dou by dou z dot del I dot I1, j dot j1, k dot k1. Therefore, del dot del is dou square by dou x square plus dou square by dou y square plus dou square by dou z square. This is the value of del dot del, that is del square, which is allowed to operate on f. The value of f is I into x plus 2i j plus 3z k. See here, if this operator dou square by dou x square is allowed to operate on this function, we may get 0 because dou by dou x of x is 1, dou square by dou x square of x is 0. Dou square by dou y square is allowed to operate on this function, the result is 0. Dou square by dou z square is allowed to operate on this function, the result is 0. So that del square f is 0. Already we have had grade of div f is equal to 0. Then del square f is also 0. Therefore, for the given value of f, del cross f, that means curl of f equal to 0. See this problem. Consider a rigid body rotating about a fixed axis with uniform angular velocity omega equal to I omega 1 plus j omega 2 plus k omega 3. Prove that angular velocity omega equal to half into curl v. Here v is our linear velocity. The value of v equal to omega cross r. Now we have to write the value v equal to omega cross r, which is equal to I j k, then omega coefficient of I omega 1, here omega 2, here omega 3, then r position vector is I into x plus j into y plus k into z. This is the value of v. This is equal to I into omega 2 z minus omega 3 y minus j into omega 1 z minus omega 3 x plus k into omega 1 y minus omega 2 x. Omega 1 y minus omega 2 x. This is equal to I into omega 2 z minus omega 3 y plus j into, just interchange this, omega 3 x minus omega 1 z plus k into omega 1 y minus omega 2 x. Now we have to find out curl V, del cross V, which is equal to determinant I j k operator dou by dou x, dou by dou y, dou by dou z. We have to present V. The coefficient of I is this much, omega 2 z minus omega 3 y. The coefficient of j is omega 3 x minus omega 1 z. Coefficient of k, omega 1 y minus omega 2 x. Now we have to simplify this. This is equal to I into dou by dou y of omega 1 y minus omega 2 x minus of dou by dou z of omega 3 x minus omega 1 z. Then minus j into dou by dou x of omega 1 y minus omega 2 x minus dou by dou z of CM, this column, this row, dou by dou z of omega 2 z minus omega 3 y plus k into dou by dou x of omega 3x minus omega 1 z minus dou by dou y of omega 2 z minus omega 3 y. Now simplify this, which is equal to I into dou by dou y of y is omega 1. Dou by dou y of this term is 0. Minus dou by dou z of this term is 0. Minus dou by dou z of minus omega 1 z is plus omega 1. So item is over. See here, dou by dou x minus dou by dou x of omega 1 into y, 0. If this dou by dou x is allowed to operate on x, we may get 1. So minus to minus plus. Therefore, we may write plus j into omega 2. See here, dou by dou z of omega 2 into z is omega 2. Already minus is present here on minus. So this is plus omega 2. Then come to k dou by dou x of x 1. So write down this omega 3. Then dou by dou x is operating on this 0. Minus of dou by dou y of omega 2 into z 0. Minus dou by dou y of minus y. Here 1. Minus to minus plus. Here plus omega 3. See, this is equal to I into 2 omega 1 plus j into 2 omega 2 plus k into 2 omega 3. Here the left hand side is curl V. Del cross V equal to 2 into I omega 1 plus j omega 2 plus k omega 3. This is our capital omega. So curl V is 2 times capital omega. Therefore, angular velocity omega equal to 1 by 2 curl V. Now, up to this problem, prove that angular velocity omega equal to 1 by 2 into curl V. Here V is our linear velocity. Hence, we are to do this. Angular velocity omega equal to 1 by 2 into